verify Kirchhoff's first and second laws. 2. Apparatus 1. Board network 2. Several resistors with different resistances. 3. 2 power supplies. 4. Voltmeter 5, ammeter 6. Connecting wires. Nummernzahl 3. Why Kirchhoff's laws? Kirchhoff's laws are used in the analysis of complex electric circuits, especially when there are more than single loops. 4. Kirchhoff's current law, KCL. The algebraic sum of current into any junction is 0. Equations 1, I1 minus I2 minus I3 equals 0, 2. I1 equals I2 plus I3. Meaning KCL is a statement of charge conservation. Junction labels shown mom1. Junction point, A2. Incoming current, I1, 3. Outgoing current, I2, 4. Outgoing current, I3, 5. Circuit of the experiment. Main circuit labels 1, J1, 2, J2, 3, J3, 4, R15, R2, 6, R3, 7, E1, 8, E2, 9, I1, 10, I2, 11, I3, 12, node A13, loop 1, 14, loop 2, 6. Kirchhoff's voltage law, KVL, the algebraic sum of the voltage potential differences in any closed loop must equal 0. Loop rule 7. Meaning of KVL. As you go around a loop from a certain point, the starting point has the same potential as it did when you began, so any increases and decreases along the loop have to cancel out for a total change of 0. 8. Sign conventions. 1. Through an EMF from negative to positive, delta V equals E2. Through an EMF from positive to negative, delta V equals minus E3. Across a resistor in the same direction as current, delta V equals minus IR, nudum mas. 4. Across a resistor opposite the current direction, delta V equals IR, nudum was. 9. Loop equations. Left loop, loop 1. E1 equals I1, R1 plus I3, R3. Right loop, loop 2. E2 equals I3, R3 minus I2, R2, 10. Experimental procedure. Step 1. Connect the circuit as in figure 7.4. Step 2. Determine the resistance of the 3 given resistors using their color codes. Step 3. Measure the electromotive force of the 2 power supplies E1 and E2. Step 4. Measure the voltage drop across each resistor R1, R2, and R3. Step 5. Record the polarities of V1, V2, and V3. Step 6. Measure the current through each resistor. Step 7. Replace one jumper at a time by the ammeter. Step 8. Find the sum of the currents I1, I2, and I3. Step 9. Find the sum of voltage drops and electromotive forces through each closed loop. 11. Measuring voltage and current. A. Voltmeter. 1. Measures the voltage drop across each resistor. 2. When the red terminal of the voltmeter is connected with the positive side of the resistor, the sign of the reading will be positive. B. Ammeter 1 measures the current by replacing one jumper at a time. 2. When the red terminal of the ammeter is connected with the positive side, the reading will be positive. 12. Data tables. Table 7.1, E1, volts, E2, volts, V1, volts, V2, volts, V3, volts, R1, ohms, R2, ohms, R3, ohms. Table 7.2. Current experimental values, calculated values, percentage difference, I1, I2, I3, 13. Final verification, KCL I1 plus I2 plus I3 equals first loop E1 plus V1 plus V3 equals second loop E. 2 plus V, 2 plus V3 equals third loop E. 1 plus E2 plus V1 plus V2 equals 14. Final conclusion. Kirchhoff's current law is related to charge conservation, and Kirchhoff's voltage law is related to the cancellation of voltage changes around a closed loop.